All right, we're going on to now past paper questions. And the first question I'm doing is on page 62. So let's read the question. So we're going to underline keywords as we read. This is a very straightforward question. Okay, I shouldn't say that. All right. So let's look at this. It says in the figure, O is the center. I want you to underline that word. I want you to underline where it says O is the center. So if we know that O is the center, what theorems are coming to your brain immediately? Go back to your spider diagram that you drew earlier. Someone tell me.
So line from the center, sir. Line center quarter rate tangent, sir. Angles at center.
There's no tangent here, so that shouldn't be coming to your brain, but it's good that it's coming. All right.
Oh,
I'm thinking angle at the center. All right, which we're going to use.
A bow tie method, sir.
Sorry?
A bow tie method, sir.
No. I'm talking on the word center. Let's just zoom into center. All right. Don't use that word bow tie again. All right. We're going to use now angles in the same segment. But angles in the same segment has got nothing to do with the center. Okay. And if you carry on reading the question, they tell us that AEB is equal to 39. All right. So the first question is to find O1. So I'm going to ask myself a question. O1 is the angle at the center. Which angle is O1 actually equal to? So if we trace angle O1, which chord is producing O1? We have chord AB. But chord AB also produces an angle at the circumference, which is 39. So what would angle O1 be?
39. Oh, no. Sure, angle at center, sir, 2 times angle to the circumference, sir.
So what will we get? 78. Are we all happy with that? So our first answer is 78. And what reason would you say? Angle at the center. Are we all happy with that?
Yes, sir.
So the second question now is to find O2. Now, there is a hint here given, and the hint is that AB is equal to DC. Now, I know maybe you haven't done this in class. Now, they're telling us those two chords are equal. Now, there is a deduction that O1 is actually equal to O2. So we can say O2 is 78. Now, there's two ways I can prove to you that O2 is 78. And what the first way would be
vertically opposite.
Sorry?
Won't it be vertically opposite, sir?
No, that will be incorrect because the lines are not straight. BOD is not a straight line, so we can't use vertically opposite.
So wouldn't it be equal chords equal?
Thank you. Equal chords produce equal angles at the center.
Equal angles.
Okay. Or another way to look at it, if you can't see that way, you see that we have the radii. AO is a radii, OB is a radii, OD is a radii, OC is a radii. So those two triangles are actually congruent. So because of congruency, O1 is actually equal to O2. Okay. So we have two ways. We can either show it by congruency, or the easy way is equal chords produce equal angles at the center. All right, so we get our O2 to be 78, and I would use equal chords at the center. All right, I can say produced equal angles at center. Are you guys happy with that? Very simple question. Any questions on this one?
No, sir.
Right, we're going to go to page 65. You see there's page numbers in the bottom, 62. Now I can't do everything, so I'm just going to skim through some questions, and we can come back if we have time, all right, to more. So let's read this question. So on page 65 we are. It says in the figure, QS and PR are diameters. Now let's underline, that's a big word for us, diameter. Immediately, what are you thinking when you see that word diameter?
Semicircle. I mean, angles in a semicircle, sir.
Thank you. Well done. So let's get the diameter. So according to this question, which is the diameter? QS. So if QS is a diameter, we immediately can conclude that this angle here has to be 90. But they also tell us that PR is a diameter. So you need a pack of highlighters, all right? Can you see that? Highlighters are very helpful in geometry. Okay, so if we look at the other diameter, and the other diameter given there, let me just get to that, is PR. So if we look at PR, so that angle here has to also be 90. Are we in agreement there?
Yes, sir.
Okay. So we're moving on to the question. It says PQ is parallel to RS. Now I'm gonna try not to highlight too much because I'm gonna make the diagram a little too full. So if PQ, if you think parallel lines, just understand that. What is coming to your brain at this moment?
Alternate angles, sir. Corresponding angles and co-interior angles.
Thank you. So as soon as you see parallel lines, we're looking for alternate, co-interior, and corresponding angles. So keep that in the back of your mind. Then they tell you that Q1 is equal to Q2. So let's make a note of that. We don't know what it is. So we're just going to put a dot here and a dot telling us that they actually equal. Then it goes on to say RS intersects QN at M and S1 is 48. So we're ready to start the question. The question says, firstly, find angle Q1. So, okay, somebody is shouting at us. Put your mics on mute there. Mr. Neil, who's Neil? Neil, mute. All right. So, let's look at that question. We want to find angle Q1. Does anyone know what angle Q1 is equal to?
So, will it not be 24, sir, because of exterior angles of cyclic quad, sir? Because the whole of Q is 48, sir.
Brilliant. Guys, did you see that? So let me show you if you missed that. So if we're looking at the cyclic quad, 4 points, touching a circle, all right? We notice that the outside angle is 48. So if the outside angle is 48, we can conclude that the whole of angle Q is 48. But we know on the top they told us that Q1 is equal to Q2. So that has to be 24 and 24. So to write that out for 3 marks, you first got to tell us that angle Q is equal to 48 degrees. And your reason there is exterior angle of a cyclic quad.
Excuse me, sir.
Yes.
So, how did you know that the line QS bisects Q equally, sir?
They tell us on the top. Read the top. Can you see where I'm ringing this? It says Q1 equal to Q2.
Oh.
You see why it's important to highlight that information, because when you get into the question, you may forget. So if you highlight those key things, you can always look on the top. Whenever you need help, look on the top. Okay,
yes,
that answers your question.
Thank you, sir.
And then from there, we can say, all right, Q1 is equal to 24. And our reason is, it's on the top, Q1 equal to Q2, and that was actually given. Are we all happy with that?
Yes, sir.
Okay, so we finished the first question. The next question is to find angle R. Okay, so to find angle R, I just want to zoom into angle R there. Does anyone, before I come into the picture, can anyone tell me what angle R is actually equal to? I'd like you to think.
Yes, I can try. So,
What do you think?
so since P, so is a diameter and is equal to 90, so it's kind of in the middle. So wouldn't it be therefore 45, so? And then the whole of S43 would be 90, so you'd say 100 minus 180 minus 90 minus 45, so.
Okay, I'm gonna let's just check if you're right or wrong. Okay, what did you say your R was?
So I said you'd say 180 minus 90 minus 45 because 45, sir.
Okay. I'm not sure how you got 45, to be honest with you. All right. So I just want to show you very quickly how I am thinking about this one. So when I look at angle R, I'm thinking, what is the angle R equal to? And I'm looking from chord PS. If you look from chord PS, let me just highlight that chord for you with another color. Let's go with blue. So if we look at chord PS, so we have angles in the same segment. So can you see that we have, and I can actually draw it in for you. But when I'm drawing it in, I'm just messing my diagram. Can you see that 24 and angle R has to be 24? And a simple reason I'm going to use is angles in the same segment. Are we all getting that? So that's 24. And I'm going to say angles in the same segment. So what I'm basically saying, sorry, Mr. Neo, I don't know who's Neo, but please put your mic off. All right, so we have 24 because angle R is equal to Q1. Are we all good with that?
Yes, sir.
Yes,
I'm
sir.
just going to get rid of some of the markings on my diagram because it's now a little overloaded, all right? So we're coming back to the basics on what you're seeing. All right, so we now got our 24. The next question is to find angle M1. Anyone has any ideas? How can we find M1? So you ask yourself a question, what is M1 actually equal to? And I'm noticing it's below the parallel line. So very quickly, if you draw your parallel lines, so angle M1 is on the right-hand side of the parallel, it's on the right-hand side of the transversal below the parallel line. It has to be equal to the whole of Q, corresponding angles. Are we in agreement?
Yes, sir.
So that has to be 48 degrees. And your reason there would be equal corresponding angles, QP parallel to RS.
Yes, sir.
And then we go to the most difficult question in this is a proof. Whenever they say us proof, you know, we got to think a little bit. And we normally would use the theorems, but the converse of the theorems. So in this question, they want to know from us, prove that ST is a tangent to a circle passing through M, S, and N. So they want to know that, okay, prove that there's a circle passing through that. Okay, so we want to prove. So the best thing we could prove is for it to be a tangent, it means that if S1 is 48, angle M1, well, we found it in the last question, to be honest with you, which I didn't write down. M1 we said was 48. And let's write that down. We found that to be 48. So it's actually proven. We just got to write it out. You see, S1 is 48 and M1 is 48. That is the converse of tan chord theorem. And only exists. Yes. Sorry, somebody asked me a question. So let's see, what do we know? We know that S1 is equal to 48. Okay. That's given information.
Sir?
We also know that M1.
Sorry, sir.
Yes.
So where can we find these recordings, sir? Because I'm in the BE and I feel it's upper now.
I'm gonna send it to your teacher. You must communicate with your teacher or share it on your Teams group.
Okay, thank you very much, sir.
Okay, so M1 is 48 and S1 is 48. So we have the 10 chord theorem that is in existence. So therefore, we can conclude now that S1 is equal to M1. All right, because both are 48. And therefore, we can now conclude that that ST, we can actually copy this whole statement down and write it down here. That ST is a tangent, and your reason would be, well, that's the converse of the tan chord. Okay, so whenever we're proving, we're going to use the converse of the theorem. Okay, and if you actually look at it now, for that to, if that's a circle, can you see SN is the chord, ST being the tangent. So the angle between the tangent and chord is equal to M1. So because S1 is equal to M1, we're now using the converse of tan chord theorem to prove there must be a circle passing through M, N, and S. Okay, can we move on? I want you now to turn to page 75. Going to page 75. I'm just looking at variety, different types of question. 73, 74, and we're on 75. So I'm going to give you some time to quickly read the question if you don't have a copy in front of you before we get started with that.
Hey, sir. Sir,
Yes.
I'm a bit confused with the converse thing, sir. Does every theorem have a converse theorem as well, sir?
No, you see, it's like this now, okay? I mean, we're using the reverse of the statement. We're saying if you have to prove two lines to be parallel, they're
Yes,
not
sir.
parallel, but if you're going to prove two lines to be parallel, so we look, if the alternate angles are equal, then the lines are
And it's
parallel. So we're using the reverse of the statement. Does that make sense?
Oh, okay.
Okay.
Oh, yes, sir. Yes, sir.
If you think about a cyclic quad, if they just
Yes,
give
sir.
you a quad, now if you want to prove that there is a circle passing through the quad, if you show that the opposite angles are 180, if the opposite angles are equal, if the opposite angles are supplementary, then we can conclude there must be a circle passing around it. How did we prove that? We're using the reverse, which we call the converse of the theorem that states that the opposite angles of a cyclic quad are supplementary. So whenever we're proving, our reason is going to be the converse of the theorem. But we've got to show that the theorem actually exists in that situation. But we'll do more, you'll get used to it. Okay,
Yes, sir.
has everyone had a chance to read this now? Keyword, center. So if O is a center of the circle, okay, what are you looking at in terms of the theorem, or what's coming to your mind? Okay, let's carry on reading. This says the diameter LR. So what can you conclude if LR is a diameter? Nobody? Somebody?
So I'm thinking semicircle, sir.
Right. Which angle? Which angle? You're thinking right. Well done.
So angle K, I think so.
Yes. Angle K immediately is 90 degrees. Can you see that? And actually, that is the first question. The first question is to find LKR. And immediately we can say LKR is 90 degrees. What is your reason for that?
Angles on a semicircle.
Angle in the semicircle. Well done. Okay, let's carry on. We carry on reading the top. At the circumference of the circle, N is another point on the circumference, and chords LN and KN are drawn, and they tell us that L1 is equal to 58. So we answered the first question. Next question is to find angle R. So let's put a dot on angle R. How can we find angle R?
So we can use some angles of a triangle, sir.
Brilliant, brilliant. We're looking at a triangle. So if you look at this triangle, for those of you who cannot see it, there's our lovely triangle. We have two angles, that's 90. And we know the other angle is 58. So we can use some angles of a triangle giving us 180. Can I have an answer? Did somebody work that out? Did you get 32 degrees?
Yes, sir.
And what reason would you have?
Yes, sir.
We'll have
Some angles
some
of a triangle, sir.
angles of a triangle. Now, if you don't have your reason right, you're going to lose marks. Now we come to angle N. So if we want to find angle N, we want to work backwards. What is angle N actually equal to?
So 32, sir, to R.
How did you get that so quickly, young man? What's your justification for that?
So I think it's the chord center theorem, so something like that.
You lost the marks. He doesn't know his theorems.
Angles in the same
Angles
segment.
in the same segment, sir.
Oh,
Angles in
yes,
the
yes,
same
that one.
Angles in the same segment.
circle.
So he would have lost his mark for the reason. Can you see that? A very simple question.
Excuse me, sir. Can angles of the same segment work if NK is not passing through O as the center of the circle?
Yeah, it does. Angles in the same segment got nothing to do with the center, all right? For angles in the same segment to be in existence, the 4 point that you're using, can you see from chord LK? 1, 2, 3, 4. Those 4 points must touch the circle. So from LK, can you see that?
Yes, sir.
So it's got nothing to do about a center. Angles in the same segment, that's 32, that's 32. And if you actually look from NR, from chord NR, we can say that L2 should be equal to K2. Can you see that?
Yes, sir.
It's got nothing to do with, doesn't have to pass, or it doesn't have to be a diameter. The 4 points must touch the circle. I'm quite happy with that question. Let's go to page 83. Okay, we're on page 85. Did everyone get to page 85?
Yes, sir. Yes,
Right.
sir.
Now, the first part is a theorem. We're not interested in that. I told you to look at the videos. You'll be able to. So we're going to go to 11.2. So I'm going to give you some time to read, maybe 5 minutes, and start the question, and then I'm gonna come into. I don't want to just carry on without you reading first and understanding. So let me give you about a couple of minutes, read, start, and then we'll come together in about 3 to 5 minutes time. All right, did everyone have a chance to read the question?
Yes,
Hello?
sir. Yes,
All right.
sir. Yes, sir.
Okay, so let's start the question now, right, together. It says in the diagram, Pn is the diameter. So if we look at Pn being the diameter, immediately what is coming to your brain? What is running to your brain if Pn is a diameter?
So the semicircle, sir.
Angle in a semicircle. So which angle will be 90?
R1 and 2.
Sir,
sir.
R, sir.
R1 and 2. Be careful, not the whole of R, just R1 and 2. So you want to mark that to be 90. Is that fair?
Yes, sir.
Okay, we carry on reading. We have a circle center. I want to put a dot there. That dot tells me that that's the center. Now, if that's a center, it's also good to know that all the radii, all the lines that come from the center would be equal. Would you agree with that?
Yes, sir.
Yes, sir.
And he tells me RT is a tangent. RT is a tangent. What theorems are coming to your brain right now?
tan chord.
Angle subtended, sir.
Chord theorem, sir.
Chord theorem, I'm thinking chord theorem. If I look at chord theorem, from the tangent R3 should be equal to P. I'm also thinking a radius is perpendicular to a tangent. Am I right?
Yes, sir.
So it means
So what about
R2,
angle?
R2 and
Angle
R3,
subtended.
R2 and R3 is going to be 90 degrees. Let's keep all this in the back of our mind. We're not going to put in a diagram. It's going to flood the diagram. So I'm just pointing it out. We'll come back to it a little later, right? So it also tells me an important point, OT is perpendicular to NR. If OT is perpendicular to NR, they marked angle S to be 90 there. What theorem is coming to your mind? What theorem is coming to your brain?
Radius tan, sir.
Sorry? Okay, the theorem that's coming to you.
Same segments are equal, sir.
No. I'm talking about this point. If OT, if this angle S is 90, and remember it's coming from the center, that's the chord theorem. So it means that S will also be the midpoint. Okay, we're going to use that a little later. Okay, so we're ready to start the question. The first question is to prove that TO is parallel to RP. So what I'm going to do firstly is I want to highlight those two lines.
Yeah.
So let's quickly get those two lines into our focus, all right? So we're looking at the two lines. They want us to prove that TO is parallel to RP. Now, if we want to prove that TO, now they're not parallel, but if we want to prove that TO is parallel to PR, let's think what should happen. If the lines, let's ask ourselves a question. If the lines were parallel, it would mean the alternate angles will be equal. So I'm going to work a backward process. It means the corresponding angles should be equal. So if I can show that the alternate angles or the corresponding angles are equal, then that means the lines are parallel. Are we in agreement?
Yes, sir.
So if I look at the diagram immediately, where the lines are parallel, I can see, I already concluded this earlier on, that R1 and R2 is 90. But they also told me that OT is perpendicular to NR. So it means that S1 and S2 on the other side is actually equal to 90. So can you see that the corresponding angles are equal there?
Yes, sir.
And if the corresponding angles are equal, then we can conclude that the lines are parallel. So we now need to write that down. So we're going to say R1 and R2. So R1 and R2 is referenced by the angle PRN is equal to 90. Now we got to give them a reason. Why is PRN equal to 90? Can I have a reason?
So angles of a semicircle.
Angle in a semicircle. Well done. Angle in, I can't complete this, but remember it's angle in the semicircle. You can complete it. I don't have the space. The second thing I want to say, and I marked it, that angle S2 is equal to 90 degrees. Now, why is S2 equal to 90 degrees?
Perpendicular angles, sir.
Very good. Given, that was given that OT, I'm looking at the top, can you see that? OT was perpendicular to NR. So therefore, we can now conclude that angle S2 is equal to PRN because they both are equal to 90. And therefore, TO is, now we're going to end with the question. TO is parallel to RP, and those are equal corresponding angles. Are you happy with the write-out?
So I'm a bit confused there, sir.
Yes.
Which angles are making the two lines parallel, sir?
Can you see I marked it for you? R1 and R2. and S2. Because the corresponding angles are equal, can you see S2? Okay, let me get my,
yes,
sorry. Okay, I just want to quickly get my highlighter out, all right, so that we can. Okay, so can you see S2? That's 90, that's what we proved, and R1 and R2. And that's the reason why we're actually saying that. Okay, are we ready to move on?
yes, sir.
Okay, the next question wants to know from us. Okay, I'm gonna rub that out. I think you can look at it later, but I just want to rub this out and clear my writing space here. Okay, the next question. It is further given that TRN is X. Let's quickly mark that. TRN, that's X. Now, if that is X, but before we go on, I just want to quickly go and say, we prove these two lines are parallel. Now we can put the parallel lines in there because we've proved it, so we can use it if we need to later on. Now, so if they tell us that TRN is X, name two other angles equal to X. Go for it. Who can give me two angles? Nobody? Somebody?
I
So
think
wouldn't it be P?
P is equal to R3.
Why? Everything you tell me, you gotta have a reason. If you can't give me a reason, then we're in trouble. Somebody
Exterior angles of a triangle, sir.
Sorry?
Exterior angles of a triangle.
No.
So could you
Sir,
not say
the tangent and the chord.
Yes. Let's think about what's happening here, guys. This is an angle between the tangent. Can you see the tangent there? And the chord. So what theorem are we using? From this chord Rn, we have an angle produced which is equal to X. So we're using the tan chord theorem. Are we all in agreement there? Angle P
Yes,
is
sir.
equal to X. Why is angle P equal to X? Tan chord theorem. Are we happy with that?
Yes, sir.
Okay, so angle P is equal to X, and I said, all right, we're using a simple tan chord theorem. Now, they said two angles, so we got one. Can somebody tell me what the other angle would be?
So N2, sir, is equal to X, sir, because of tangents from the same point, sir.
Well done. Did they tell us that that's a tangent? RT
Oh.
is a tangent. They don't tell us that Rn is a tangent. Can you see that?
Yes, sir.
If they told us that, I would like to say that it was a tangent. So I'm trying to look at the top there. All right. NT, where's N? Yeah, N is on the circle. It would be a tangent. But I think the safer way to let's look at parallel lines. So Q3 has to be X. So now Q3, O3. Why would O3 be equal to X?
Angles on the same segment, sir.
Wrong. Taking a big chance. Angles on the same segment. The points must touch the circle. I'm using grade 9 maths to prove that O3 is X. Who can tell me? Equal corresponding angles. Can you see corresponding angles?
No, so can't see.
Why you can't
see
see?
that, sir.
Sorry?
So what do you mean,
The lines are parallel. You know
oh,
what
yes, okay, so
Yes.
grade 9 maths
Okay.
we're going to.
Oh,
Corresponding angles are equal. Can you see above the purple line, on the right-hand side of the transversal? So we got O3
Yes,
is
sir.
equal to P. Let me mark them for you clearly. If P is X, O3 is X. equal corresponding angles. And you got to tell the writers, all right, we are using QT is parallel to PR. Can you see it now?
Yes, sir. Yes, sir. Yes, sir.
Well done. And we answered the question. Would you agree with that?
Yes, sir. Yes, we did too.
All right, so we're moving on to the next question. So the next question is stating, prove that NTRO is a cyclic quad. NTRO. Now there's a lot happening in my diagram. I just want to clear out some lines for you so you'll be able to see a little clearly. All right.
So can we still prove that, sir? Because she's outside the circle, sir.
Yeah, they want us to prove there's a circle going through. Don't misunderstand the question.
Oh,
Okay.
okay.
They are telling you, we know there's no circle. So let's quickly highlight that. It's a little too thick. So firstly, highlight those 4 points. Step 1. So step 1 is take NTRO. Let's highlight it. Now, they want us to prove that there's a circle passing through those 4 points. Now, for it to be a cyclic quad, one of the theorems that we have studied has to exist. That means we're using the reverse. In other words, if we look at this case, if the opposite angles are supplementary, then it's going to be a cyclic quad. Or if the exterior angle is equal to the interior, or one of the other theorems. Now, when you look into the diagram, the first thing that is striking my eyesight here is I'm looking at O3 and R3. What is O3 equal to? X. What is R3 equal to? X. All right. Why is O3X? We proved that above. Am I right? Proved above. And R3, why is R3X? That was given. Isn't that the angles in the same segment? Look at that. From chord NT. Can you see that? If the angles in the same segment are equal, then it has to be a cyclic quad. I'm now using, it's not a cyclic quad. Whenever I'm using the reverse, we're going to say converse. So therefore, let's conclude O3 is equal to R3. Okay. And if O3 is equal to R3, therefore, question, NTRO is a cyclic quad. And what am I using? If you look above, those are angles in the same segment, but it's not a cyclic quad. I'm proving it a cyclic quad. So on top of it, I'm going to say converse, angles in the same segment. Okay, I'm giving you some time to digest that.
Sir, I understand everything else, so I'm just confused. How does this prove that it's a cyclic quad?
So what is the theorem saying? Let's think about the theorem. Theorem states that in a cyclic quad, the angles in the same segment are equal. So let's go to the reverse. All right. The reverse will mean if the angles in the same segment are equal, then it has to be a cyclic quad.
Oh, okay. So
now, not all converses are true as well, but we will assume that these converses that we are using now, not assume, they are true. I'm trying to think of in real life, you know. You can use some illustrations to explain that. Okay, can we go on?
Yes, sir.
Just waiting for some people to finish up. Okay, the next question wants us to find M in terms of X. So anyone has any ideas how we can find that? Just want to clear my diagram a little bit. How can we find M in terms of X?
So since MPR is a triangle, so we might say 180 minus the x of P minus the x of R3 and 90 of R1 and 2. So it's gonna be 90 minus 2x, I think.
Brilliant. So this young man is telling us, look at the big triangle. So let's highlight it. And M is part of that big triangle. Now, if M is part of the big triangle, we can use some angles of a triangle. So in other words, he's telling us, all right, this angle here is X. This whole angle here, in other words, the whole of angle R, we have a 90 and an X. So that's a 90 plus X. So to find angle M, I just want to get some space to write because we can see the diagram. So to find angle, we can use some algebra. In other words, angle M has to be equal to, we can take 180 minus the two angles are 90 plus X, that's angle R, and angle P is X. And if we work that out, 180 minus 90 is 90, and an X plus X is 2X, so we'll have minus 2X. So we end up with angle M, and the reason we're using, we should state this, is some angles of a triangle. Are you with me there?
Yes, sir. Yes, sir.
Okay, let me give you some time to think about the next question. I'd like you to think first before we get into it. Back on. All right, so going back to this question, all right, the last question. It says, show that NT is a tangent, all right? And in the last question, okay, remember we proved the lines were parallel, so I just want to put my information back. I think we proved that P was X. Would we agree with that? We also proved that O3 was X. Okay. And then we also proved, if I'm correct by saying this, that R3 was also X. Yes or no?
Yes, sir.
Okay, that's what we know. Everyone still with me? So what will make NT to be a tangent? You tell me. If we want to prove that NT is a tangent.
So if N2 equals X, sir.
Hey, that's a good point. If he says if N2, he wants to use N2. If he can find N2, all right, and if N2 is equal to X, then he's going to use the tan chord theorem because P is X. Is that your thinking, young man?
Yes, sir. Yes, sir.
So how are you going to prove that to me? Can you find it? In other words, that's what I'm asking you.
Not yet, sir. I'm still thinking, sir.
Okay, well done, well done. But also remember, I don't know who asked me that question. Somebody said, is R2 and 3X, 90? Can we mark that one? Remember that this angle is 90. Would you agree with that?
Yes, sir.
Okay, now.
So couldn't you also prove?
Yes.
Couldn't you also prove N1 and 2 is 90, sir?
Why not N3? You're right. Can we agree that N3 is 90 degrees? The reason why N3 is 90 degrees and N1 and N2 is 90 degrees is because in the previous question, 11.2.3, we proved that NTRO is a cyclic quad. You remember that?
Yes, sir.
Yes.
Now, yes, somebody was saying something important. Right, carry on. I know what you want to say, so carry on now. Is N1 and 2 90? Yes, it is. Opposite angles of a cyclic quad are supplementary. That's what we use. Yes, carry on. Tell me what you're thinking now.
Ish, sir.
Now, isn't O the center of the circle N?
Oh, yes, sir.
Now, if O is the center of the circle and N1 and N2 is 90, so in which theorem? Do you remember the theorem that says the radius is perpendicular to tangent?
Yes, sir.
Now, there's a theorem called a radius is perpendicular to tangent. Think about that. That's a hint I'm giving you. Carry on. So how can we use that?
So, sir, if the n, sir, is equal to 90, sir, and it's because of radius tan, sir, doesn't that mean radius to tan, so NT is a tangent?
Exactly. It makes NT the tangent. We're using the converse. You see, we're not saying that N1 and N2 is 90 degree because of tan chord. No, not sorry, tan chord. We're not saying because the radius is perpendicular to tangent. We're saying this, that N1 and N2 is equal to 90 because opposite angles of a cyclic quad are supplementary. R was 90. Are you with me? And because this angle here at this point is 90 degrees, so it means that NT has to be a tangent because a radius is perpendicular to a tangent. Are you guys with me now?
Yes, sir.
And that proves it. Okay. I wanted to go to one more question, 87, before we close. Because of time, I'm going to do this last question. So if we go to this question, I'm going to work it with you because of time. So let's quickly get into this question. In the diagram, O is the center. Okay, if it's a center, lots of things are coming to your brain at this moment. The diameter DE is perpendicular. So if a line from the center is perpendicular, what is your conclusion?
PC is equal to CQ, sir.
Well done. It means that C is the midpoint. So we can quickly mark that. That is equal to that. And then it goes on to tell us that DE is 20. And if we go to DE, that's the diameter. Now, if O is a center, how long is DO? 10. Am I right?
10.
Yeah, if DE, so we've got 10 and OE. OE will also be 10. Okay. And they tell us that CE is equal to 2. So I'm going to take that down. If CE is equal to 2, I want to take out this 10 now because we got more information coming in. If they tell us CE is 2 and we know OE is 10, how long is OC? 8.
8, sir.
8.
I got load shedding at 6. That's why I have to end in the next 5 minutes, all right? I have load shedding coming up very soon. Now, let's quickly read the question. Calculate the length with reasons of OC. Now, let's look for OC. Oh, we found it. What is OC?
We found
8. Okay.
What's the reason, sir?
All right. Now, firstly, I think we must say that OE is equal to 10. And what's your reason for OE to be 10? Isn't that a radius?
Radius.
And then we can say, all right, well, that OC is a mathematical calculation, 10 minus 2 giving you 8. We don't need a reason for that. Your next question is to find PQ. Now, to find PQ, oh, we don't have any lengths there. So the trick here is to complete the triangle. if you complete a triangle, you got a right angle triangle. Can you see that?
Yes, sir.
Now, how long is OQ?
10, sir.
Sorry?
Yeah.
Sorry, how long is OQ? Let me draw that again.
Sir, would it be
OQ
wrong
is
if you
also a radii. Can you see that it has to be 10? Would you agree with
Yes,
that?
sir. Yes, sir.
Because DO is a radii 10, so OQ is also 10. Any questions on that one? In other words, I'm saying
No,
you
sir.
that have to be the same. They are radii. Now we have a right angle triangle. Let's draw it in red. And what can we use in a right angle triangle to find CQ?
Pythagoras, sir.
Pythagoras, sir.
Well done. CQ squared will be, the radius is 10 squared minus 8 squared. And that gives you CQ squared to be 100 minus 64. You can use your calculator, which gives you 36. And that gives you CQ to be 6.
Yes,
But
sir.
the question is to find what? PQ.
PQ, sir.
PQ, sir.
PQ has to be now 12. Now we need a reason. And the reason is line from center.
From midpoint.
And you see it was given to be perpendicular to the chord. And that's how we know that PQ is 12, because it's doubled. So that's a simple Pythagoras question we looked at. Gentlemen, thank you very much.